Industrial robot reach and payload. So that's a reach diagram. It's showing you how far the robot can reach. And this is a payload diagram showing you how much load the end of the robot can carry. These are the two things which define which robot arm you need. So how heavy is the tool that you're handling? Where does the tool need to get to? And so you have all these different types of robots, all these different models, all with different reaches, all with different capacities as well. So we have to configure or work out which model of robot is going to be able to reach everywhere you need it to reach. Some of these will work upside down, some of them work below themselves and stuff like this. Some of them are designed for stacking things, and so they only have 4 axes and they only work in quite a narrow work envelope. It's obviously a donut round the robot, but it's essentially only works in certain directions. And basically we're going to have to work out what the payload you're going to carry and how far you need to move it. And so this is a load of ABB robots, all the same model, but different variants, and some will have more powerful motors and stuff, but typically as you increase the payload, so the amount you're carrying, then the reach decreases and vice versa. So the longer the reach, the lower the payload. And so when you look at the reach on an ABB, it's to the middle of the wrist. It's not the sort of final end point of the robot. It's the point at which the robot can move the tool to anywhere in that space effectively. And the tool can extend that. And as I say, it's kind of a donut round the robot. So the reach, it goes to axis 5. It's not including the tool. So if you've got an application which needs a really big reach, what you can potentially do, as long as the tool is relatively light, you can extend the effective work envelope using the tool. The payload is to the end of the arm, so that's the quoted payload here, and you can see as the centre of gravity moves away, so as the tool gets bigger or further away, then the payload decreases. So if you do that trick extending the reach using the tool, then you have to keep in mind that issue. But the centre of gravity is the thing which you need to watch. But that's just on the end of the arm. There is usually extra on the arm itself. So the robot arm will have mounting points on it where you can add extra weight. So you can sort of carry harnesses and carry extra equipment. The payload which is specified is always talking about the end of arm. So distance equals lower payload, so the greater the distance, the greater the reach, then you lower the payload, and you always want to overspec if possible. Moving on to that, a standard robot is always cheaper, has better parts availability, and there's more support for it. So avoid odd configurations and niche models. So when I say a standard robot, what do I mean? Well, I mean a car factory robot. So something like this, our friend the IRB 6700 here, used by the 100 in car factories. So they're very, very common, and they're used in a whole range of different applications. And so these robots, especially a used robot, is going to be much, much cheaper than something in the middle of the range. So when we look at these Yaskawa robots, you can bet that certain models are going to be far rarer and far harder to get parts for than the standard car factory robots. So we have to keep in mind that it's usually worth speaking to whoever's selling you the robot and saying, look, I just want a standard off the peg one. I don't want anything flash. And then you overspec it. So get something which is bigger, get something which is more powerful than you need, but it's probably going to cost you slightly less money because it'll be a stock robot model as opposed to something which is a bit niche or a bit strange. Now, I would say that the palletizing robots are the odd one out here because they have fewer motors, and so they're by design less expensive. But yeah, basically that's what you do. You work out how far your robot's got to reach, you work out what the payload is, and then you choose your model. And then you think, well, what are the standard model? What's the next size up, which is a standard robot for that manufacturer? Because if you ask them, it will probably be a lower price than the thing which is bang on what you need.